Okay, so in the last class we have discussed about first law of thermodynamics. Okay, so there we have told like heat input goes to do two things. One is to increase the internal energy. Another thing is to do some work. So that equation what we had discussed was like del Q is equal to del U plus del W. So this is your heat input. This is the change in internal energy. This is the work done on the system or work done by the system on the environment. Okay. So now today we'll discuss about thermodynamic processes. Okay. So there are different types of thermodynamic processes that we'll discuss, like one ideal Carnot engine. Okay, so we'll discuss it in the future classes, where it has four different processes: two isothermal process, two adiabatic process. So, what is an isothermal process? What is an adiabatic process? Uh, how much is the work done during an isothermal process? How much is the work done during one adiabatic processes? Those things are important to know for us. Like in a heat engine, it is important for us to know what is the efficiency of the heat engine. So we'll be discussing in future, like efficiency is nothing but output by input. Okay. So in case of a heat engine, your output is nothing but your work done. Your input is nothing but your heat input. Okay. So efficiency is equal to work done by heat input. Okay. So in heat engine, you are converting the chemical energy to mechanical energy. So mechanical energy is something what you need. Okay, like for example, when your car is moving, you are getting the kinetic energy. That's what you need. So you are converting the chemical energy of the fuel into a kinetic energy. So heat input or the calorific value of the fuel, that is the input. Whereas the kinetic energy, the rotational energy of the fuel is the output. Okay. So and there are different types of thermodynamic processes. So we'll start with isothermal process. Okay. So iso means equal. Thermal. So thermo, it is related, comes from thermal. So that is temperature. Okay. Iso means equal. Thermo means temperature. So equal temperature. So in during a process, if the temperature remains same, that is called isothermal process. Okay. So you can see here I have just drawn a PV diagram for a isothermal process. Okay. So so in a uh, in a this kind of a XY graph, you can plot only two variables. You cannot plot three variables. It is not a 3D graph. It is a 2D graph. So here you can see the gas. Let us say it is the arrow is something like this. The arrow is something like this. That means initially uh, the gas is at a pressure P1, volume V1. Then finally it expands and goes to a pressure P2 and volume V2. So when it is traveling from pressure P1 to P1 V1, pressure P1 volume V1 to pressure P2 volume V2, let us say the temperature remains constant. Okay. So if it is something like this, let us say we were discussing about the piston cylinder. Okay, so let us say you have a cylinder, you have a piston. Okay, So now let us say initially your pressure and volume are P1, V1, okay, and let us say it expands, okay, let us say it has expanded, okay, it has expanded. That means my gas has occupied the complete volume, and after expansion, the pressure and the volume become P2, P2, but the temperature remains constant. So when it is expanding, the temperature is remaining constant. So when temperature remains constant, that means it is absorbing some heat. See, when it is trying to expand, what is happening? The temperature will try to go down. Yes. But if you keep supplying some heat from outside, then if you keep supplying some heat from outside, then only you can keep the temperature constant. See, when the expansion happens, there is a tendency of the gas temperature to go down. So during isothermal process, you are supplying heat, right? We'll just talk about adiabatic process. Then that time there is no, you are not supplying any heat from outside. But in isothermal process, you supply heat from the outside to make the temperature constant. Clear? So that's what we are telling. Like in this case, what is happening actually? You can see it is going from state 1 to state 2. Okay, it is going from state 1 to state 2. That means in this process, V2 is greater than V1. So when V2 is greater than V1, work done is greater than 0. Yes. Because it is done to. Yeah, because you know W is equal to P into V2 minus V1, right? So in this process, actually, what is happening here? Volume. How do we derive this equation? Okay. So let us say you take an infinitesimal change of state. Okay, infinite, very small. So during that process, let us say this is almost a straight line. Almost a straight line. In integration, the way yes, you do integration. So here, let us say this is a completely straight line. If it is a straight line, what does it mean? That means the pressure is completely constant. So the pressure is constant, but the volume changes by infinitesimal of volume, which is nothing but B2 minus B1, which is dV. Okay, so you can see your when del V tends to 0, that means infinitesimal. So when del V tends to 0, then your del V tends to 0. That means this del V is otherwise become dV, right? Yes. Del V we call it as dV. So your del W will become dW. Okay, del becomes D, very very small. Okay, so your dW will become equal to PdV. PdV. Okay, so now applying the principle of integration. Okay, so you know my work done, the total work done. Okay, my total work done when my piston expands from this position to this position, I am supplying some heat from outside. It is not a adiabatic wall, it is a isothermal wall. Adiabatic wall is something where it is completely insulated. Okay, yes. No heat can come inside, no heat can go outside. But in isothermal, there will be heat exchange. So your work done is equal to PdV from lower limit V1 to upper limit V2. Okay. So as you know, the ideal gas equation is PV is equal to mu RT. Okay. So that we have decided, discussed earlier, like PV is equal to mu RT. This is the ideal gas equation. Okay. So here mu is equal to number of moles, R is universal gas constant, and T is the absolute temperature. Okay, so this is absolute, means Kelvin, that you have to remember always. So PV is equal to mu RT. Okay, so if PV is equal to mu RT, that means this P will become what? P will become mu RT by V, right?
Yes.
So in place of P, you write it as nu RT by V. Okay, and then this is dV. Okay, so if it is P is replaced by nu RT by V, and this is dV. Okay, so this nu is constant, R is constant, and in this case temperature is also constant in isothermal, in particular in isothermal. So whatever is constant, you can bring it outside take it outside, and nu RT into dV by V, integration of dV by V from V2 minus from V1 to V2. So this dV by V integration is nothing but ln V. Okay, so dV by V integration is nothing but ln V, right? Yes. This you have to logarithm. This is ln means logarithm base base e. Okay. Yes, there are two logarithms. One is log and one is ln. Yes. In log the base is 10. In ln the base is e. Okay. So it becomes ln v from v1 to v2. Okay. So this becomes nu RT into this ln upper limit is ln v2, lower limit is v1, so ln v2 minus ln v1. Yeah. So this then finally the work done becomes W work done is equal to nu RT into ln v2 minus ln v1 is nothing but ln v2 by v1.
ln minus ln v.
So ln v2 minus ln v1, that is another important thing in logarithm. So ln v2 minus ln v1 is nothing but ln v2 by v1. This is another important equation from logarithm. Okay. So this here first ln v2 minus ln v1 that get converted into nu RT into ln v2 minus ln v1.
V2 by V1.
Sorry, ln v2 by v1. Okay. So so this is an important equation. There can be numericals. Okay, on isothermal process. Okay, somebody will ask. Okay, the volume changes from this mmq to this many mmq, and at this temperature it happens. Please find the work done. Okay. So this importance of this work done you will get to know only when we solve a problem related to Carnot engine or any heat engine. You will get to know why it is so important to calculate the work done. If you know the work done, then only you can calculate the efficiency. Okay, it is very important for a heat engine to know its efficiency. Yes. Okay, like say if we say a four-stroke engine has a better efficiency than a two-stroke engine. Okay, so what is four-stroke? What is two-stroke? As I told, as I was explaining, there is suction, there is compression, there is power, there is exhaust. So that is in any internal combustion engine like a petrol engine or diesel engine, these four processes happens. So in a four-stroke engine, the fuel efficiency is better because all four processes it takes it takes four strokes. Okay, whereas in case of engines, these four in two-stroke engine, all these four processes will complete in two strokes only.
So okay. Efficiency is less.
That's why two-stroke will not have better complete combustion, so efficiency is less. So that is so it is very important to know the efficiency. So what does efficiency mean? That means whatever heat I have, like say petrol or diesel, it has some calorific value. So I want ideally I want the efficiency to be 100%, which is not possible because some heat will go to the atmosphere because the just gas is going to the atmosphere. So there will be some amount of energy remaining with that. So I cannot use 100% of the energy. That's why the efficiency comes into picture. So our intention is always to increase the efficiency as much as possible. So and the heat input that you already know that okay, this is my calorific value. So let us say I am using 1 liter of petrol. So for 1 liter of petrol, I know what is the calorific value. So there is nothing to calculate there. Calorific value, you can convert it into joule, that becomes heat input. But work done, you have to calculate. So if you calculate the work done, then only you can calculate the efficiency. So the whole intention of finding the work done is to calculate the efficiency, and higher is the efficiency, better is better it is for you. Okay, and that means you are using your money, you are like the petrol, you are spending money. If you are increasing the efficiency, the fuel efficiency, that means it is something desirable. Okay. So that's why people go for four-stroke engine. They don't go for two-stroke engine because it has better efficiency. That means the mileage for a two-stroke engine, a four-stroke engine, we are saying its mileage is 80 kilometer per hour. Whereas your scooter, it has mileage of just 40 to 50 kilometer per hour. Sorry, per liter, not kilometer per hour. Like mileage means how far a vehicle can go by spending 1 liter. Okay. So if I spend 1 liter of petrol in four-stroke engine, it will go up to 60, 70 kilometer. Whereas if I spend the same amount of petrol in case of a two-stroke engine like a scooter, it will go only up to 40, 50 kilometer. Okay. So the mileage, higher is the mileage, better it is. Okay. So that's why we need to know like where the efficiency is better. Okay. And we'll study about Carnot engine. Carnot engine is the ideal engine. Okay. So that no, the efficiency of a Carnot cycle is the highest. Those things we'll discuss. Okay. So now this is our work done. Okay. So for an ideal gas, internal energy depends only on temperature. Hence, in isothermal process, change in internal energy is equal to zero. Because internal energy depends on temperature. Why? Because it is a gas. Okay. So if you are supplying some heat, it will increase the temperature, and because of which the molecules will have higher translational kinetic energy or rotational kinetic energy and all that. But if the temperature remains constant, the translational and rotational kinetic energy will also remains constant. That means if the temperature remains constant, there is no further increase in the translational or rotational kinetic energy of the gas. That's why the internal energy remains constant. The internal energy depends on temperature. If temperature is constant, then there is no change in internal energy. That means there is no change in the kinetic energy of the gas. Okay, understood? Yes. No? That point. Yes. So in isothermal process, del U is equal to 0. But we know that like del U is equal to 0. If this becomes 0, your del Q becomes equal to del W. That means whatever heat you are supplying, it is going to do the work only, not to increase the temperature or not to increase the temperature or do some increase the internal energy. So del Q by del W is otherwise known as Q is equal to W. Yes. Whatever heat you are supplying, it will do the work only. Okay. So, Q is equal to W. Okay. So there can be two types of isothermal process. One is your isothermal expansion. Okay. Another is your isothermal compression. So in this case, it is like expanding. Okay. Yeah. There can be some process where the piston comes to this stage. Volume decreases. That means that is compression. Yes. When volume decreases, that is compression. When volume increases, that is expansion. Okay. So in isothermal expansion, V2 is greater than V1. Okay. That means when volume increases, work done is greater than 0. Why is it so? Because W is equal to P into V2 minus V1. Okay. Let us say the atmospheric pressure is let us say 1 bar, which is nothing but 10 to the 5 Newton per meter square. That is 1 bar that we have studied. Like 1 atmospheric pressure is equal to almost equal to 1 bar or whatever. Like because 1 atmospheric pressure, we are studying 1 atmospheric pressure or 1 atta is equal to 76 mm of Hg, which is nothing but 1.013 into 10 to the power 5 Newton per meter square, right? That's what we have studied, right? So, which is, this is 1 into 10 to the power 5 Newton per meter square is nothing but 1 bar that we have studied, right? We are discussing what is 1 bar, okay? So, 1 bar is equal to this much, okay? Um, 10 to the power 5 Newton per meter square. That is 1 bar, okay? Uh, remember, no? That one, okay? 1 bar, okay? So, so I am telling work done is equal to P into V2 minus V1. So 10 to the 5 Newton per meter square into, let us say, the volume changes from let us say 1 meter cube to 2 meter cube. So the volume becomes 2 meter cube, 2 minus 1. That means it's a positive number. That means in isothermal expansion, this becomes a positive number, right?
Where increase in volume.
Increase in volume. So when the volume, let us say here it is, let us say the volume here it is 1 meter cube, here it is 2 meter cube. Okay, that is the expansion. Okay, that means when like I finally I have calculated this one. Okay, I got the work done to be mu RT ln V2 minus ln V1. So if V2 is greater than V1, that means this term is a positive term. Okay, so in expansion, work done is greater than 0. Whereas in compression, V2 is less than V1. That means this is sorry, meter cube. So if it this would, from this to this, it is expansion. But if we are coming from in this direction, the reverse direction, if we are coming in the reverse direction, let us say we are coming in the reverse direction. We are coming in the reverse direction, right? So if you are coming in the reverse direction, that is compression. So when you are compressing from 2 to 1, that means your second state is 1 meter cube. Okay. Your first state is 2 meter cube. That means what it will become, instead of becoming 2 minus 1, it will become 1 minus 2. So if it is 1 minus 2, that means it's a negative number. If it is a negative number, that means work done is less than 0. If it is expansion, work done is greater than 0. If it is compression, work done is less than 0. Okay. So, so in isothermal compression, work done is on the system by the environment. So when I am compressing, that means the system is doing some work. On the system, the environment is doing some work on the system. That means this is my system. It is getting compressed. So somebody is doing some work. So what kind of, how will do the work? Suppose you put some weight on this system. That means work done on the system by the environment. Okay. But in expansion, work done by the system on the environment. So so work done on the system by the environment, and when work done is on the system by the environment, it is getting compressed. When it getting compressed, it has a tendency for increasing the temperature. The temperature will increase. When you are compressing the gas, the temperature will increase. So what you, that time you have to release the heat. Yes. So in compression, you release the heat, whereas in expansion, you observe the heat. So that's the difference between isothermal expansion and isothermal compression. In isothermal expansion, you observe the heat. In isothermal compression, you release the heat. So, in a nutshell, uh, for any numericals, what are important? One is you must know how to like nowadays there is no derivation. In our time there is to be derivation. You will derive the work done. So somebody will ask, please derive the work done during a isothermal process. So now if you don't have to derive, at least you have to remember, okay, work done in the isothermal process is equal to mu RT into ln P2 by V1. So you can, so using this equation, you can solve a number of numericals, okay. That is one, so that is the takeaway from this, okay, isothermal process. This is the work done. And another important thing is there is no change in internal energy because there is no change in temperature. So heat input is equal to work done. There is no change in internal energy. This is another takeaway of isothermal process. And some there can be a objective type of question like in isothermal expansion, heat is absorbed or heat is released. The answer is heat is absorbed, and in isothermal compression, the heat is released because it is trying to get heated. You want to keep the temperature constant. That's why you have to release the heat. So here I am telling there are two types of wall. This is a isothermal wall. In isothermal wall, there is heat exchange with the surrounding. But in adiabatic wall, there won't be any heat exchange.
Insulate.
It's insulated. Okay. So, so this equation, and no change in internal energy, absorption of heat, and release of heat. These are the 5 to 6 takeaway of isothermal process. Okay. So next we'll be discussing about the adiabatic process. Okay.